The next thing we need to adjust is outfeed table parallelism with the cutterhead. Your cutterhead is always your reference point. Everything gets adjusted off of that. So the cutterhead's your reference, then the outfeed table gets adjusted, then your infeed table, a reference to your outfeed table. And what I mean by parallelism is that the height, the difference in height between your outfeed table and your cutterhead at top dead center is the same all along the length of the cutterhead. But basically we're going to make sure that the table isn't slanted right now. So in order to do that, you're going to need two things. You're going to need feeler gauges, and I hate to say it, but you're going to need a good quality straight edge here. The other things, you want to wear gloves here so that you don't transfer any oil onto your surface here, which hopefully you have prepared so it doesn't rust. Make sure you wipe it down so there's no dust or anything to interfere with your measurements, and also wipe your feeler gauges off. And there's these two lock nuts in the back here, these two lock screws, I suppose. And I need to loosen those so that I can move my outfeed table up and down. So we need to check parallelism between the cutterhead and the outfeed table. And how I'm going to do that is use a straight edge, and I'm going to measure at 3 different points along the outfeed table. Here at the one edge, in the middle, and then also at the far edge. And the way I'm going to do that is rotate the cutter head until we reach top dead center. Top dead center varies on a spiral cutter head because it doesn't have the straight knives, right? So you have this spiral pattern. Top dead center is basically the highest point of this cutter head along the axis of your straight edge, which means you have to rotate it to get this surface right here that I'm pointing at anytime you take a measurement along there. Okay. So I'm going to go up. I'm going to bring the table up, rotate to top dead center, and then bring it down so that it's still slightly above the cutter head. If I get it just a hair above the cutter head, I can resolve it down to about 1/2 mil. Because I have a 1.5, a 2, a 2.5, and a 3. So the difference between those at the smaller scale is only 1/2 mil, which gives me incredible resolution. Let's see that we're above 1/2 mil, or 1.5. Okay, so that goes under. It's a good sign. Let's go to 2. 2.5, 3. All right. So we're catching at 3, and 4 will not go under. So we're going to go ahead, check the center next. It's just a hair lower towards this end than this end. And that may be due to the cutter face differences, because it seems like the middle was about the same as the far edge. So I'm going to try one more spiral here, just to be sure. So I think what I'm seeing is just a little bit of variation along the cutter head, top dead center, because I had to scour this a little bit with some steel wool and a scouring pad. As you can tell, it was a little bit rusted. I cleaned it up pretty well, actually. But really that doesn't matter at all, because this surface will always be below the cutter head, and I didn't do anything with these surfaces, which are the critical ones. So I think this is fine. Basically we have about 1/2 mil variation between one end of the cutter head to the other, depending on which spiral I'm on. And I'm totally fine with that. So I'm just going to go ahead and leave that as is. But basically, if I needed to adjust the outfeed table, I need to adjust these eccentric bushings here. I'm just going to go ahead and leave that as is, and I'll show you how to do it on the infeed. You do the same thing on the outfeed if you needed to, but we're just going to leave this as is and call that good. Now that we've confirmed parallelism between the outfeed table and the cutter head, the next thing we need to do is adjust the outfeed table to its final position, its final height, in reference to the cutter head. Now, There's three possible positions for your outfeed table height compared to your cutter head. That's high, at the exact same height, or a little bit low. And let me talk about each one of those. So I'm going to adjust the outfeed table to exaggerated positions to demonstrate what can happen if it's not in the right position. So first I'm going to go up. So if your outfeed table is too high, meaning it's higher than top dead center of your cutter heads, your wood piece is going to come off the cutters and the bottom edge is going to be below your outfeed table, which means this is going to happen. Impacting it, it's just going to stall, or you're going to have a safety issue. Now, if your table's just a little bit high, it may keep going. The wood piece may ride up onto the outfeed table, but what happens is, let me put it back in exaggerated position. What happens is you get this slanted effect, right? If it rides up onto it, it's going to slant here until about midpoint, and then you're going to get the snipe at the on the other half of the wood piece. So you never really want the table to be above your cutter head. So conversely, if your outfeed table is too low, it'll cut fine until about halfway, and then when you're pushing on this side, it's going to do this. And you're going to get this kind of weird snipe, especially on the ends. And you don't want that either. So it's not going to bind or anything, but you're going to get bad snipe. Now finally, if your outfeed table is perfectly aligned with top dead center of your cutter heads, your workpiece will move over smoothly, no problem. The issue is that if you adjust it perfectly to your cutter heads as they are now, they're going to wear over time. And then your cutter head surface in reference to your cutter heads is going to be high again. And as I mentioned, that's the worst condition. So what you want to do is adjust to where your cutters are now perfectly, and then go maybe just like half a mil or a mil lower. And really that's going to cause an inconsequential amount of snipe there, because wood flexes a little bit anyway. Now for this step, we need to actually insert a cutter because we need to figure out the proper height. So top dead center of the cutter head, you're going to have to rotate a little bit because it's at an angle. It's at about right there. That's about its highest point. Alright, so I'm going to take my straight edge and place it above my cutter that I installed and torque to spec. I'm going to move my table up, and it's important to make sure your straight edge is not contacting the infeed table for this step. And then you're going to rotate it through top dead center like this, back and forth, because it's kind of hard to find exact top dead center. So just keep rotating it back and forth through, and you're going to move your table down. You'll see the straight edge move as it makes contact with the cutter head. And as I said, we want to go slightly below, so we want it to move just a tad. And I have a ruler here, and as I rotate it through top dead center, I'm going to see how far it moves. So based on some testing I just did, when the straight edge moves about 1/4 of an inch, it gives me about 4 mils worth of gap between my outfeed table and my straight edge. So I'm going to go about 1/4 of that. That'll give me about 1 mil, somewhere around that neighborhood. So it's moving about a little over 1/16. Let's see if we can get a 1.5 mil. So we're rotating through less than 1.5 mils, and that's fine. So when I'm at my desired height, based on the movement of my straight edge, what I need to do is tighten these bolts here. Okay, so I've tightened my bolts here, and I'm just going to rotate through top dead center one more time to make sure nothing's shifted. And I'll show you what I'm doing here. I'm just going to align my straight edge here to the 1 inch mark, and then I'm going to rotate through. And it moved, I'd say about 1/16 of an inch, maybe 3/32, somewhere around there. And that's great. I'm perfectly happy with that. So outfeed table height adjustment done.